All right, so let's get started. Um, Today I'm just going to do something very quickly. Um, I do not have a lot of. What's this? Let me set it to 30 minutes. Christ. Anyways, so what else? What am I saying? So content edit. Yes, I'm going to be talking about binary search and perform some binary search questions. I mean, solve some binary search questions, and then I will. Um, so let me quickly explain. I'd solved this question already, but it's quite easy. And sorry, let me come here. So the first question I'm going to solve is this one, which is a binary search problem, and it's the title is search insert position. So given a sorted array of distinct integers and a target value, return the index of the if the target is found. If not, return the index where it would be if it were inserted in order. So you must write an algorithm with O log n runtime complexity. So here's an array. We'll be given an array as our input and the target, right? So I'll quickly explain how we do this. So since we are going to be using binary search, the steps are just going to be really simple for us to solve this question. I'll increase this a bit. So here is our array, right? And we have our target is 5. So our target is 5. This in this case, this is very easy to do, right? I'll just remove this 1 2 3 5 6. So let me remove this and write it myself. All right. 1 3 2 1 3 was so 1 3 5 6 1 3 5 6 is our input array, and we are looking for a target equal to 5, right? Our target is t equal to 5. Now when we use binary search, um it's it shortens the amount of time or amount of elements we have to look through to get our targets, right, in the array. So when we divide this, so with binary search we perform a division, right? So we start with 2 pointers, the left and the right pointer at this point, right? And we get the midpoint by just adding these two values and dividing them by 2 and rounding the value or the results of that expression to the nearest 0 value, right? So it's going to be L. So I'll put mid. The midpoint is going to be L plus R, right? Now the division we are going to use is this double division so that we round it up immediately, divided by 2. Now this is going to be at position 0, this is going to be at position 3. So the answer here is going to be 0 plus 3, right? 0 plus 3 divided by 2, which is going to be 1.5, but we'll set it to 1, right? So meaning our midpoint, our mid value is at this point here, which is 3, right? This 3 here is our midpoint. But is this 3 superior or equal to our target, or even less than the target? Those are the 3 conditions we check when we are performing a binary search in order for us to move to the next middle, right? So the next point where there is a possibility for an occurrence of our target, right? Or there is a possibility to find our target at that point. So we'll move, since our midpoint is here, right? This is our midpoint, which is 1. this array, I'll call this x. X at index 1 will be equal to 3, right? Let me remove this. I'll say x. X at index 1, right? X at index 1, if I did this, x at index 1, this will be equal to 3, right? And we know 3 is less than our target t, right? Our target t is equal to 5. So what do? We move the left pointer, right? We move the left pointer forward. We move it one past the position where the middle was previously. So we move the left pointer to this point, and we calculate again by just doing this for a second time, right? This operation again, but this time around the left pointer is at position 2, right, and the right pointer is at 3 still. So this is going to be 5. When we divide this by 2, we would have had 2.5, but we'll set it to 2. Now this is our midpoint. Now 2 is our new midpoint, and x at index 2, x is our array at index 2, is going to be equal to 5, and we know this 5 here is equal to our target, right? Is equal to our target, which is also equal to 5. So that is how we will solve this question, by just getting half, by just using binary search and trying to get the value of our target. But the question doesn't end there, right? So the next thing is, what if the value we are looking for, right, is not in the array, right? Where would it have been if were to place it in this array, right? That's the next part of this question. So let's say we are looking for a 4, right? Our target t is equal to 4. Now, since this array is sorted, we'll get a we'll get to the point where since this array is sorted, every item will be next item will be higher than the previous, right? So if we're looking for 4, right, 4 would have been here, right? It would have been at this position here. But how do we determine that 4 would be here? So we'll still perform our binary search again, right? I'll use the binary search again. So let's start from the beginning and the end. Now when we find the first half of these two values, right, the first half here is going to be at this position, right? So the midpoint here will be here. The midpoint will be this, will be 1 in the first iteration. It will be here. Oh, come on. The midpoint will be here, and this will be 3, right? So we'll check if 3 is less or equal to our target, right? Now 3 is less than our target, so we'll move 3, the left pointer past where 3 occurred, right, or past the previous mid value. Now our left pointer will be at this position here, will be here like this, will be on top of 5. Now we'll perform the calculation again, and we'll get, so this will be 5, so this will be 2, right? This will be 2. Now the value at this position here is higher than our target, so basically our target would have appeared at this position here, right? Would have appeared at this position where our left pointer reached, right? So this is how we'll solve this question, by just simply returning. If we don't see our target in the array, right, and we know the array is sorted, then we simply return the left pointer, right? The left pointer is simply where the target would have appeared if it were in this array here, right? So let me show you how I did that. Now you can see I did the basic binary search, right? So when I look through the array, right, and I get a value or the midpoint where the value at that position is higher than the target, I'll move the right pointer towards the left, right, And then in the case where the mid value is less than the target, I move the left pointer forward, right, past the midpoint. Otherwise, when I find the target at this mid value here, or the value of the this mid value is the same as the target, then I return the midpoint, right? The midpoint is simply an index where the target is. Otherwise, the target would have appeared where the left pointer is, right? So I'd already, let me just submit this again. You can see this is a correct solution. So you can see the runtime is really good, which is 78%, not bad at all. So for in terms of memory, well, I don't know how else I would have saved the memory here, but yeah, I think that is okay. So I see why this is the memory here is you know increasing. If I had done this directly here, I think the memory would have been saved a bit. So let me just remove the mid value here. Okay, so when I submit this, I think, well, the runtime increased, which is better, but in terms of memory, it's still the same. So no biggie, no problem. All right, I will put this solution. So this is 35, right? LEETCODE 35, binary search insert position. So I'll create a folder. For my binary search. A file in my binary search folder. So it's number 34, right? Say lead 34. Hold on. Also 35. Search dash insert dash position. Okay, so let's import these types here, and this is all we need to do. I'll submit this in let's see. So git add, git commit -m. I'll say lead dash 35, sorry. So okay, so this is a binary search, binary search problem, right? LEETCODE 35, and I'll submit this. So let's move on to the next question. The next question is a medium question, right? And this question is quite interesting. It's also on binary search. So the question is asking us to find the first and last position of an element in a sorted array. Now, let me read the question. It says, given an array of integers, nums, sorted in non-decreasing order, which is increasing order, right, from smaller values to bigger values, find the starting and ending position of a given target value, right? If target is not found in the array, return -1, -1. You must write an algorithm with O log n runtime complexity. So nums, these are nums, and here's the output here. So we've been given 8 as our target, right? So we first of all find the occurrence of 8 in the array, the first occurrence and the second occurrence, right? So the same thing happens here. We are looking for 6 as our target. 6 is not in this array, so we return -1, -1. and when the array is empty, we just return this as well. So for us to do this, we know we'll have to perform um, uh, a binary search, right? A binary search will simply give us O log n time complexity for searching for the value in the array. That is, one of the things we'll do. But then when we get the first occurrence, right? I mean, with binary search, we only search for a specific target in an array, right? I'm not saying that's the only thing you use binary search for, but like, most of the time we're searching for something in a sorted array, right? So with that, we can first of all look for the first occurrence, right? We know these occurrences will happen on two sides, right? We can call them the first and the last one, right? The first one will typically be on the left and the second one will be on the right. So which means we'll perform a binary search, two binary searches, right? Separately. So the constraints are quite, understandable. We have, from, zero, the norms could be zero, right? Which is an empty array. And the values here, could range from negative, how many is 100 billion? I don't know, 10 to the power of 9. And norms is okay, is a non-decreasing array, which means it's sorted. It is sorted in an increasing order. So our targets could be anything as well. So let's go ahead and solve this question. So what I'll do is I would just copy this, right? This starter LEETCODE 34, and I will code it straight away here. So we'll do this binary search. So lit dash 34, and I'll say find start and end. Find start and end. Okay, that's not bad. So I'll just put this like this and import this, this list type. Okay, so like I said, we'll perform two binary search. One binary search will look for the starting point on the left, right? Since we are dividing the array into half, right? To search for our value, we'll look for the starting point in the first half, which is towards the left, and the second or the end point towards the right, in the second half. So we'll perform two binary search. Now there's going to be a little difference here, right? Even when we find the value, even when we find our target, we'll continue looking for the target towards the first, towards either half, right? So it could be the first half or the second half, which is on the right and left respectively. So I'll define a function here. I'll define this function. I'll call it search first half, or I should say I'll call this search left here, search left, and here I will pass it the target. Now I could pass it the norms as well, but I just pass it the target straight away, since I'm using the same norms array to perform this calculation. So as usual, we'll have a starting point and an end, right? So you will have our left is going to be left and right pointers, right? left and right pointers. So I'll set this to be equal to the start and left, sorry, the length of the nums array minus 1. Now, so we'll run a while loop, right? A while loop that says, while this is just basic implementation of a binary search. So while left and right, right, like this. Then we'll find the midpoint. Midpoint is here. Midpoint is going to be equal to, I'll just say mid. Let me just call it mid. Is going to be equal to the division of this, the left and right. So left plus right divided by 2. These are midpoint. Now here's what we need, we're doing in a simple binary search. We usually say so if the so here's what we need to do in this case, right? Since we are looking for, we are going to be looking into the first half towards the left, right? We need to get so we say midpoint, right? The midpoint should be if the midpoint, if the nums at the midpoint, right, if the nums at midpoint is equal to the target, right, if it's equal to the target, then here's what we need to do. We'll simply so we are searching towards the first left, so we'll change our right pointer, right? So say right should be equal to the midpoint, right? Midpoint we are going to move the right pointer towards the so I'll say midpoint plus 1, right? Midpoint plus 1, no, midpoint minus 1 as usual, right? When we find that particular midpoint, so we'll move it towards the right, towards the left. We'll move the right pointer towards the left so that we'll look into the first left half. So we'll say otherwise if if the nums, so if the nums here, right, at this midpoint is less than the target, right? If it's less than the target, then we would simply move the left pointer forward, right? Left plus equal, sorry, not plus equal, set it to, so normal binary search, right? So we'll say midpoint plus 1, our midpoint plus 1. Otherwise we just say else the right pointer, right, the right pointer should just be equal to the midpoint, so yeah, the midpoint minus 1, right, minus 1, like this. Now you can see we are setting the right pointer to the same thing twice, right? This is just to help us shift the right pointer towards the left anytime we find the midpoint, and we'll continue doing this until, okay, so we want to return the midpoint, right? I mean the starting position. I'll say this will be first first starts. I'll call this first. Let me just leave it to first. Set first to be equal to -1. So this will help us, so whenever we find this first, right, whenever we find the midpoint in this target, we'll set the first to that midpoint, right? To that midpoint, and move the right pointer towards that side, so that we are we stay on the left side, right? We look into the first left half. I don't know, maybe I'll still go over this to explain it again. So let's do for the second one, search right, search right, and I'll still pass in the target again. Well, we're basically going to repeat the same thing, but this time around it's just a minor difference that will happen here. So I'll just paste it here again, and instead of, we could still call this first, but let me change it to second, and second here, second. And instead of us to move the right, since we are searching inside the second, so search, I'll call this search right into the second half. We'll move the left pointer, right, left plus 1, right, like this, and we have our second. Yeah, so each function has to return a value, right? So I'll just return first here, and then return second in the second array, in the second function. I'll say return second, like this, return second. So this is all we need to do. Now the next thing to do is to check if our first, so let's say if the first is -1, right? If the first is -1, it means we were out of the array, right? We were out of, we went past the start of the array. We went out of range. So basically, there would not be a second point if there is no start. So let's say I'll call this first point, right? First point is simply going to be equal to, I'll call this search what was it called? Search left. Come on, what's this? Oh, search left is going to take the target, right? And then we'll say if search left, if the first point or starting point is equal to -1, right? Let's just return -1 and -1. Otherwise, we'll get the second left. So I'll say the second point is going to be equal to the search right of the target, right? And then we'll just return the first point and the second point here. So here's all we need to do. Just perform binary search twice, looking within each half for the target. So I'll just run this here. I'll go over this question again and explain it properly, because I'm in a bit of rush. I think I didn't do a good job on the explanation. So you can see we passed the test cases here, and let's submit this to see how it works. Hey, hello. So I mean, this is not the best of solutions, but it actually works. We can work on optimizing this later on. So I just quickly want to round up for this session. So I'll just do git. Thank you very much. You're welcome to the stream. Git add git commit, and I'll say here we'll just do commit lit. So this is also a binary search. I'll say bin search, leet code leet dash 34, I think. Yeah, 34. And git push origin main. Now you can get the link to the solution in the description. The GitHub repository is in the description, so you can have access to that and try and understand the solution. I will explain this again tomorrow. I am in a bit of rush, so we'll continue tomorrow. See ya. Bye. I did exactly 30 minutes.